All of you to Annie Maths. This is my first video in congruency of triangle. Now congruency is done in 7th standard also and then again in 9th standard. But then in 9th standard what happens is the concept remains the same. Only thing is the sums become little more difficult, that's all. Okay, so I shall be taking up the main concept with some other examples, go through it. Whether you are in ICSE or CBSE, the matter is same, the concept is same, even the sums are same. So please go through the video and go through both the videos, go through the first and then go through the second. That is what I have always been telling you, okay, so that you understand the concept properly. Okay, then let's go to the sums. Okay, so let's see first what is congruence. Okay, let us see what exactly is congruence of, in our syllabus we have congruence of triangles. But then we will see first that two other geometrical shapes can even be congruent. Like if we have two circles, okay, these two circles, the simple meaning of congruence is if you have two circles and assuming you can cut them out of paper, okay, you cut them out of paper, and if you can place one circle over the other and it exactly fits over the other, that means they are exactly of the same size. Okay, they are exactly of the same size, then that is the two circles now look like one circle. Okay, that is you have cut them out of paper. Unless you touch it, you don't understand that there are two. It fits exactly one over the other. Then you can even call these congruent circles. Now that is possible only when both the circles have equal radius. Okay, then it is possible. Similarly, we can take two squares, and two squares can also be congruent to one another. Okay, remember these two squares I shall be calling congruent to one another if they are exactly of the same size. Okay, not the area. Okay, do not compare the area, but exactly of the same size means you cut them out and place them over the other and it looks like one square, then the two of them are congruent squares, and that is possible only when you have the sides of the squares are equal. That is, if this is a 4 centimeter, 4 and a 4 and a 4 and a 4, 4 centimeters. Okay, so this makes it congruent squares. Similarly, we can have congruent triangles. Okay, congruent triangles are figures, two triangles, not figures, two triangles which have exactly, so now here again same thing, same logic works for this also. I have two triangles here and in both the triangles the sides have to be equal. That is, if this is a 5, this has to be 5, 6, okay, this is 6, okay, and say this is, let's say this is 4, okay, so then this too has to be 4. Not just that, the sides have to be equal and the angles, this angle has to be equal to this one, this angle has to be equal to this, and this angle has to be equal to this angle. Then these two triangles are also congruent triangles. That is, again, if I cut out both the triangles from paper and I try placing them one over the other, then the sides should match and the vertex also should match. That makes them congruent triangles. Now here in this chapter we are going to do only congruent triangles. Now remember one thing, it is not always possible to cut out triangles from paper, as I was just talking about. Okay, it's not possible for you to cut out paper from the question paper and then check, but they will give you two triangles and they'll give you some data, not everything. Okay, they will tell, maybe they'll talk about two sides and one angle. Okay, so they'll give you some details about this and this triangle, okay, about the two triangles, and they will expect you to test and find out whether those two triangles are congruent to each other or not. So without practically trying to see if one fits over the other exactly, how do we understand? We have to understand by We have to understand by certain tests. There are certain tests which tell us that these two triangles, that two triangles are congruent to one another. Okay, so we'll have to learn those tests. For congruence of triangles, there are 4 tests in all. Okay, so let us see what those tests are. Let us take the first one, which is I have one triangle over here and another triangle I have over here. In geometry, it really doesn't matter if the triangle is given this way or upside down like this. Okay. Now this one is a 5 centimeter. This is a, let's take it as a 7, and this is a 6. Okay. Then they have told us this, and they have also told us that this is a 5, this is a 6, and this is 7 centimeters. They are all in centimeters. So now we'll have to tell whether they are congruent or not. Okay, how do we know that? Now, as I said, there are 3 tests. If they have given us all the sides and we observe it and see, yes, 6 and 6 and 5 and 5 and 7 and 7. So we have seen that in the 3 triangles, the 3 sides are equal in length. Then we can say that the 2 triangles are congruent. We don't have to see the angles in this case. If the 3 sides are equal, that is enough to tell us that the triangles are congruent. This has been proved, and we are only using the results of the tests. Okay, so here this test, when we say that all sides are equal, is called the SSS test. Now what is SSS? Side, side and side. All 3 sides are equal. If you see this, I'll name it A, B, C and a P, Q and an R. Now there is a way of naming congruent triangles also. Very few people actually know it, and very few people actually use it. Okay, so how do we name 2 congruent triangles? Here AB, okay, AB is equal to PQ. And what is the sign of congruence? Sign of congruence is this, not equal to, it is this. Okay, this is the sign of congruence. Now we write triangle ABC is congruent to triangle, and then think. Okay, don't write PQR straight away. So first it is A, B, C. Now we have to see, we covered the 6 centimeter, then went to the 7. A, B, C. I hope you understand what I am trying to say. So here also we'll first cover the 6 centimeter while naming and come to the 7. So P, Q, R. Okay. If we write PRQ over here, thinking that anyways it is defining the same triangle. Yes, it is defining the same triangle, but when you use the congruence sign, you should follow the rule where angle A, because once we have told these 2 are congruent, it means that this angle is equal to this. Okay, these are called corresponding angles. This one, angle C, becomes equal to this one. Okay, and this angle becomes equal to this one. Okay, so angle A, the equal angles are, angle A is equal to angle P, the first position. Second position, angle B, okay, is equal to angle Q, and angle C is equal to angle R. So we have to use the names, we have to use the letters in that order. Okay, now sometimes you will see in some questions they will not give the figure at all. If you see your own question, your own textbook, you will see that they haven't given the figure at all. Okay, they have just given you a statement like this, and they will tell you find out the corresponding sides and the corresponding angles. Supposing we are doing one question like that where the figure is not there, then we'll have to say angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. Okay, that much for the 3 sets of corresponding angles. Now let's see, AB is equal to PQ. AB is equal to PQ. Then BC is equal to QR, and AC is equal to PR. Okay, how did I get it? AB is equal to PQ, BC is equal to QR, okay, and AC is equal to PR. So this is how I get my names. So the meaning of writing in this condition with the congruence sign declares that these are the equal angles as I have written here, and these are the equal sides. Okay. So we'll take up the next test. Okay. Remember, whenever we are proving congruence in a sum, if you prove, there are many questions that will rise in your mind. Okay. First you might think, why no angle is there? Okay, why shouldn't we talk about the angles? Second thing, what you might think is one test enough for proving congruence between two triangles? Yes, one test is enough to prove triangles congruence between two triangles. You don't need more than one test. So you have to see the sum, and you have to understand that, or you have to observe it, and you have to try and find out which is the test that you have to apply in this particular sum. Which test is can be applied in that particular sum. Like if all sides are given, we have to apply SSS. Okay, so let's see the next test now. This was the first test, which is called the side. Now tests are also called postulates. Okay, tests are also called postulates. You might see in some books it is used as a postulates of congruence. It means nothing but the tests for congruence. Okay, let's now talk about the next test, which is the SAS test. What is that? Supposing we have a triangle here given, okay, and we have another triangle here. Okay, this is triangle A, B, C, and a P, Q, and R. Okay, and then here in this triangle they have told angle B is a 60 degree. Here they have told this is the 60 degree. This is a 7 centimeter, this is a 6. Here I have a 7 and there is a 6. This much only has been given to us. Then how will we know that the triangles are congruent? Now what we do here is, here we are observing it that here we have a 7 centimeter, here we have a 7, another 6, and the in between angle is equal. That is, AB is equal to PQ. Okay, angle B is equal to angle P. PR is equal to BC. Okay, so we are observing that two sides and the angle which is sandwiched between them is equal. If that is the case, then we'll have to know that these two triangles are congruent. Okay, and congruent by SAS, the postulate SAS, side, angle, side. Remember, you can't write this A outside. You can't write it as SSA or ASS. You have to write it as SAS, because it shows that between the two sides lies the angle. Okay, so it is, now how do you write it? Triangle ABC is congruent to triangle. Till here I have written, and then I'll think. Okay, start with the 7 centimeter side, go to the 60 degrees, then cross the 6. Start with the 7 centimeter, go to the 60 degree, then cross the 6. So QPR. Okay, if you write it correctly, you will see that you have actually managed all the congruent sides. Angle A is equal to angle A. Okay, now if they say which are the corresponding sides, angle A is equal to angle Q, angle B is equal to angle P, and angle C is equal to angle R, like that. Okay, similarly sides also, AB is equal to QP, BC is equal to PR, and AC is equal to QR, like that. So this is how you test two triangles if two angles and the in between sides, and you see that the two sides are equal, you see that the two sides are equal and the in between angle is equal, then you are going to use this postulate of side angle side. Okay. Now we shall be taking up the next test. Okay, the next test, the third test. In the next test, we'll see that there are two triangles, okay, and in this we have, this is supposing a 60 degree and this is a 70 degree, okay, here 70 degrees, 60 degrees, okay, and then this one is given as a 7 centimeter, 7 centimeter, okay. Now you are noting clearly that two angles and the in between side are equal. Two angles and the side in between are equal. If this is the case, you can say yes, the triangles are congruent by ASA. Okay. Now sometimes two angles, you see, and the in between side. Okay. Now sometimes it is not always necessary that the picture is like this. Sometimes it can also be, see, this is how much, 130, okay, so this is going to be a 50 degrees. So supposing in one sum they have given us, they didn't give us this 70, but they gave us this 50, okay, they gave us this 50. Now what do we do? Okay, now you are seeing this and you are feeling that no test matches with it, none of the tests are matching with it, what to do now? Okay, so but then one thing, you can always calculate this, this is 110, so this is a 70, back to your test, okay. So this test is sometimes also called EAS, because if they would have given us this one as a 50 and not this, and here also, you know, they gave us a 50 and 60, then we can always say yes, this angle is going to be equal to this. Okay, so even this is considered AAS, two angles and one side, or two angles and the in between side, whichever. So I hope you understood. If they just give two angles and one side at a side, okay, you can still, you can understand that the third side is going to be anyways equal, because sum total of a triangle, angles of a triangle is 180. Okay, so now how do we name it? Okay, once again, because I am constantly trying to give emphasis on the naming system. Triangle PQR is congruent to triangle. Now I start thinking PQR. Okay, so it is not necessary that you have to say PQR. I could have told RPQ also. I could have told RQP also. Okay, but whatever I say here, now this one has to match with this. Okay, so angle P, I have gone from P, then Q, then I crossed the, so I started from the 60 degrees vertex, then I went to the 7, and then I went to the other one, that is the 50 degrees. Okay, so let's start from the 60 degree, go to the 7, and then go to the 50 degrees. So it is CAB, not ABC. Okay, so this is how you name your congruent triangles. As I said, I could have started from even RQP, but then once you write RQP here, this one think and write matching with this. So that was our third test. Now let's see what the fourth test is, the fourth and the final test. Now this is the fourth test, or the fourth postulate, where it is based on right angles. I have two right angles like this. You can already understand where the 90 degrees is here. Okay, and let's say this is a 5 and this is a 4. Okay, here is the 5, here is the 4. Now remember one thing, the hypotenuse, that is the side opposite to the 90 degree, is always going to be the longest side of the triangle. So this is 5, this is 4, this is a 5, this is a 4. Now let me name it A, B, C and a P, Q and R. Okay. Then if you have a 90 degrees, on observing the two triangles, if you see the very first thing is a 90 and a 90 degrees, okay, then you are, and then the hypotenuse is also equal. So the triangle contains 190 degrees, then it contains one hypotenuse, and any one of these two sides are equal, any one. Okay, any one of these two sides are equal. Here the case is same. So then we can say that two triangles are congruent by RHS. Okay, the two triangles are congruent by RHS rule, that is right angle, both should have right angles, then hypotenuse, both the hypotenuses should be equal, okay, and then any one side should also be equal. Okay, that makes it RHS test. So this is the RHS postulate. So with the RHS postulate, we can prove congruence. But one thing I want to tell you all here, very commonly done mistake, whether you're 9th, you are in 7th, you are always doing this mistake. The moment you see a 90 degrees in the triangle, immediately, without thinking, without observing the question, RHS. Okay, it is not necessary that the triangle having a 90 degrees should always be RHS. We'll see later in the examples that even with 90 degrees, if they've given this angle as a 45, this angle as a 45 and not given the hypotenuse, we can prove it by ASA also. We'll take up in detail later. Okay, so let's name it now. Triangle ABC, no particular way of naming it, ABC congruent to triangle. Now we'll start from the 4 centimeter side and go to the 90 degrees. So here to here, so it is P, Q and R. Okay, so this is how we named congruent triangles. Naming a congruent triangle correctly is very important. Now those were the 4 postulates that we have in congruence of triangles. Congruence requires a lot of practice, and so we'll work out sums based on these simple questions, and we'll also see how to write the sums correctly, proving, because in congruence most of the sums are proving types. So we'll see all that in our next video. Okay, so it will be marked as congruence 1, 2, part 1, part 2, part 3, part 4. Please see it sequentially. So I would say please start right from the beginning of the exercise. When you are starting this exercise, please don't try to tick mark and do tough questions first. You will only be demotivated. Okay then, so that's it for today. More in the next video. So if you have liked the video, do not forget to like, share and subscribe. Thanks all of you. Bye once again.